Alright, let's go. Number 12. The Boötes Void. A cosmic hole so massive it swallows entire regions of space like it was never meant to be filled. We're talking a sphere stretching almost 330 million light-years wide. That's not empty space. That's a desert the size of a supercluster with barely a handful of galaxies inside. Normal universe? Galaxies everywhere, clustered, connected, following the web of dark matter we mapped so carefully. But step into Boötes and it's just nothing. A few lonely pinpricks of light floating in an ocean of pure void. Astronomers spotted it back in the 1980s, and the numbers didn't add up then. They still don't. Our models from the Big Bang say large-scale structures should be smoother. Voids this absurdly huge shouldn't form. The probability is so low it's basically zero, like winning the lottery every single day for a century. Statistically impossible. Yet there it sits, mocking us from 820 million light-years away. Some say maybe a collision between universes punched this hole. Others whisper about early inflation gone wrong. Whatever the cause, the void is real, and it proves the cosmos doesn't care about our tidy simulations. It just carves out emptiness wherever it feels like it. Number 11. HD 140283, the Methuselah Star. An ancient star that looks older than the universe itself. Located about 190 light-years away in Libra, this little red dwarf has been dated to roughly 14.5 billion years old. The universe, according to our best measurements, is only 13.8 billion years old. Do the math. This star shouldn't even exist yet. It predates the cosmos that supposedly birthed it. When astronomers first calculated its age, they thought it had to be a mistake. They ran the numbers again and again. Same result. Panic set in, because if one star can be older than everything, then either our cosmic clock is broken or something weirder is happening. Maybe dark energy or inflation played tricks we never modeled, or perhaps the star formed in a pocket of the early universe that aged differently. Whatever the truth, Methuselah sits there burning quietly, a living fossil that shouldn't have had time to form. It defies the timeline we built our entire cosmology around. One star, one impossible age, and suddenly every textbook needs rewriting. Number 10 hits harder. The Hercules Corona Borealis Great Wall, the largest known structure in the entire observable universe, a massive chain of galaxies and galaxy clusters stretching over 10 billion light-years. 10 billion, let that sink in. Our models of cosmic evolution say nothing this gigantic should have had time to assemble since the Big Bang. Gravity works too slow for that. The universe itself is only 13.8 billion years old, and structures like this require way more time to clump together under normal physics. Yet there it is, a wall so vast it spans a full tenth of the observable cosmos. Astronomers discovered it in 2013 by mapping gamma-ray bursts, and the data screamed anomaly. It shouldn't form. The uniformity of the early universe wouldn't allow it, but it formed anyway. And it's still growing in ways we can't explain. This wall isn't just big, it's a structural rebellion against the laws of large-scale structure formation. If the universe can birth something this monstrous this fast, what other giants are hiding just beyond our telescopes? Number 9. Hoag's Object. A galaxy that looks like it was drawn with a compass. A perfect ring of bright young stars surrounding a core of older ones, with an empty gap in between like someone scooped out the middle. Discovered in 1950 by astronomer Art Hoag, this thing sits 600 million light-years away. Normal galaxies are spirals or ellipticals or messy irregulars, not perfect rings with clean voids. Theories tried to explain it as a collision between two galaxies, but the math doesn't hold. The ring is too symmetrical, the gap too precise, the stars too neatly arranged. It looks engineered. Physics says gravitational interaction shouldn't produce something this clean. Yet Hoag's object spins there in perfect defiance, a cosmic bullseye that refuses every simulation we throw at it. Some astronomers call it a freak, others admit it's a genuine puzzle that breaks our understanding of galactic formation. One look at it and you realize the universe has a sense of dark humor. Number 8. The CMB Cold Spot. A massive bruise in the leftover glow of the Big Bang itself. The cosmic microwave background should be almost perfectly uniform, a faint whisper of heat from 380,000 years after creation. But right there in the southern sky sits a region 1 billion light-years wide that's significantly colder than everything around it. By a lot. The temperature drop is tiny, but the scale is insane. Standard cosmology says fluctuations this extreme shouldn't exist without a massive cause, maybe a supervoid or some exotic physics we missed. The Planck satellite confirmed it in 2013, and the debate exploded. Some theories point to a collision with another universe. Others say it's evidence of inflation going haywire. Whatever it is, the cold spot is real, and it pokes a massive hole in our picture of a smooth, predictable cosmos. The universe has a scar, and we have no idea how it got there. Number 7. Those impossible early galaxies spotted by the James Webb Space Telescope. Galaxies that look fully formed and mature just a few 100 million years after the Big Bang. JWST launched and immediately started sending back images that made cosmologists lose sleep. These galaxies have well-developed spiral arms, heavy elements, and star formation rates that shouldn't be possible that early. According to our models, the first stars barely had time to ignite, let alone build complex structures. Yet there they are, shining brightly like they had billions of years to evolve. The tension is brutal. Either our understanding of star formation is completely wrong, or the universe aged faster in some regions than others. JWST keeps finding more of them. Each new discovery tightens the knot. These galaxies shouldn't exist in a young universe, but they do, and they're forcing us to question if the Big Bang timeline we cherish is missing something huge. Number 6. The OMG Particle, a cosmic ray that slammed into Earth's atmosphere in 1991, with energy so ridiculous it broke every record. This single proton carried the kinetic energy of a baseball pitched at 100 kilometers per hour. A proton, something smaller than an atom. Our physics says nothing in the known universe can accelerate a particle to those speeds. Not supernovas, not black holes, not even the most violent mergers we can imagine. The energy required defies every acceleration mechanism we understand, yet the fly's eye detector in Utah caught it clear as day. Scientists named it the "Oh my God" particle because that's literally what they said. Decades later, we still don't know where it came from. No source in the sky matches the direction. It arrived like a ghost message from somewhere beyond our physics. One particle that shouldn't have existed. One reminder that the cosmos can still surprise us with violence we can't explain. Number 5. Tabby's star. KIC 8462852. The star that dims like it's being eclipsed by something impossible. Located 1,470 light-years away in Cygnus, this F-type star suddenly drops in brightness by up to 22% at irregular intervals. Normal stars don't do that. Planets cause tiny dips. Dust clouds cause gradual fades. But Tabby's star flickers like something massive and irregular is passing in front of it. No periodic orbit, no simple explanation. The dips are too deep, too asymmetric. Early speculation ran wild with alien megastructures. Scientists hate that idea, but the data refuses to cooperate. Follow-up observations found the star itself is fading overall, losing brightness over years. Something is swallowing its light in ways no known astrophysics predicts. It shouldn't behave this way, yet the light curve keeps delivering new mysteries. Tabby's star is a constant reminder that some objects in space are playing by rules we haven't discovered yet. Number 4. The dark flow. A mysterious stream of galaxy clusters all moving in the exact same direction at the same speed, far faster than they should. Detected in 2008 through studies of the cosmic microwave background, this flow stretches across billions of light years. Our universe is supposed to be homogeneous on large scales. No preferred direction, no bulk motion like this. The motion defies the standard model. It looks like something outside the observable universe is pulling everything toward it. A massive unseen structure or another universe exerting gravitational influence. The data keeps coming back, confirming the flow exists, and every new measurement makes it more impossible. Galaxies shouldn't all be drifting together like that, not without breaking the rules of expansion and isotropy. Dark flow is the universe telling us there's more out there pulling the strings than we can see. Number 3. The axis of evil in the cosmic microwave background, a strange alignment in the largest temperature fluctuations of the afterglow of the Big Bang. The hot and cold spots aren't random as they should be. They line up along a preferred axis that points right at us, toward the plane of our solar system. Statistically, the odds of that happening by chance are tiny, like 1 in thousands. Cosmologists named it the axis of evil because it feels personal. It shouldn't exist if the universe is truly random and isotropic, yet the Planck data confirmed it again and again. Some call it a statistical fluke. Others see evidence of a multiverse or hidden physics in the early universe. The alignment breaks our assumption of perfect randomness. It suggests the cosmos might have an orientation, a direction, a subtle order we never expected, and that order points straight at Earth. Number 2. The Cosmological Constant Problem, or vacuum catastrophe. Empty space should have almost no energy according to quantum field theory, but measurements show it has a tiny positive value that's driving the universe's accelerated expansion. The predicted value from theory and the observed value differ by 120 orders of magnitude. 120. That's not a small error. That's like guessing the distance to the moon and being off by the width of the observable universe. Physicists call this the worst prediction in the history of science. Something is canceling out almost all the vacuum energy except for this tiny leftover that just happens to match what we see. No known mechanism explains it. Supersymmetry tried and failed. Every fix creates new problems. The vacuum of space itself shouldn't allow this delicate balance. Yet here we are, expanding faster and faster because of an energy density that physics says should be either enormous or zero, not this exact whisper. And number 1, the ultimate mind bender. Boltzmann Brains. Hypothetical self-aware entities that could spontaneously fluctuate into existence out of the vacuum of space due to random quantum fluctuations. In an infinitely old universe with eternal expansion, these disembodied brains should vastly outnumber real observers like us. They would pop into existence complete with false memories of entire lives and then vanish. According to the math, you are statistically more likely to be one of them than a real human born the normal way. The universe shouldn't produce observers like us in any stable way. It should be flooded with these glitchy, short-lived minds hallucinating reality. Yet here you are, watching this video, feeling solid. The paradox is crushing. It forces us to question if our entire cosmic history is just one giant fluctuation, or if the laws themselves prevent it somehow. Boltzmann brains shouldn't dominate, but physics says they would, and if they do, nothing we observe can be trusted. These 12 things aren't just anomalies, they're cracks in the foundation. Every single one of them stands there in open rebellion against the equations we spent centuries perfecting. The universe doesn't follow our script, it writes its own and laughs while we scramble to catch up. We've mapped the stars, split the atom, and peered back to the first light. Yet these defiant objects keep whispering the same terrifying truth. Reality is far stranger, far more broken, and far less predictable than we ever allowed ourselves to believe. So next time you look up at the night sky, remember this. Somewhere out there, something impossible is happening right now, and it's been happening since the beginning. The cosmos isn't just vast, it's actively impossible, and we're only starting to notice. Nick Bostrom's simulation hypothesis. Back in 2003, the philosopher laid out a trilemma that still haunts every physicist who reads it. Either almost every advanced civilization goes extinct before it can run ancestor simulations, or they can run them but choose not to. Or we are almost certainly living inside one right now. The math is ruthless. One single base reality could spawn millions or billions of simulated universes. That means the odds you're in the original drop to almost nothing. Statistically, you're far more likely to be code than flesh and blood. And here's where it gets worse. If we're simulated, then the speed of light isn't a fundamental limit, it's a processing cap. Quantum randomness isn't mystery. It's lazy rendering so the system doesn't have to calculate every single particle when nobody's looking. Fine-tuning for life? Not luck. Just parameters dialed in by whoever coded this run. Some physicists now point to recent work on information dynamics as quiet support. The universe behaves like it's optimizing data, compressing where it can, exactly the way a simulation would to save resources. We could be shut down tomorrow and never know. Every law we trust could be lines of code that somebody else wrote, and we would have no way to log out. The holographic principle. It started with black holes and the work of Gerard Tufte in 1993. Leonard Susskind took it further, and the math exploded across string theory. The idea is simple and devastating. All the information describing everything inside a volume of space is actually encoded on the two-dimensional boundaries surrounding it, like a hologram where the 3D image you see is just light playing off a flat film. Our entire universe, with its galaxies and planets and you and me, might be that kind of projection. Volume is the illusion. Depth is fake. The real stuff lives on a distant surface we can never reach. Entropy scales with area, not volume, exactly as the principle demands. Black hole thermodynamics forced this conclusion first. Then Maldaceno's ADS/CFT duality made it mainstream. Recent calculations in flat space, our kind of universe, are starting to hold up too. The space between your fingers right now isn't really there the way it feels. It's emergent from data on some cosmic horizon. Everything solid is a trick of information painted in 3 dimensions. If the holographic principle is right, reality isn't built from matter. It's built from code on a screen we can't see. And the deeper we probe quantum gravity, the more this picture refuses to go away. Number 8. The quantum measurement problem and the role of consciousness. In the double-slit experiment, particles act like waves until someone looks. Then they snap into particles. The standard interpretation says the wave function collapses on observation. Some of the greatest minds have asked the uncomfortable follow-up. Does consciousness itself cause the collapse? Without an observer, does the universe stay in superposition, fuzzy, and unreal? If that's true, then reality only becomes definite when a mind is paying attention. The cosmos needs observers to exist in any solid form. Remove every conscious being, and everything dissolves back into pure potential. Experiments keep showing the effect holds even when the observer is delayed or indirect. It raises the ugly question: is the universe creating us? Or are we creating the universe just by looking? Some interpretations go further and say the physical world is secondary, a kind of projection generated by observation itself. Your act of watching this video right now might be what keeps the walls from blurring. Without minds, the whole show might never have turned on. Reality isn't independent, it's dependent. And that makes every solid thing around you feel suddenly conditional. Number 7. Boltzmann Brains. This one sits at the dark heart of statistical cosmology. In an infinitely old universe undergoing eternal expansion, random quantum fluctuations should occasionally assemble a fully conscious brain, complete with false memories of a lifetime. These disembodied brains would vastly outnumber real, evolved observers like us. The probability math is merciless. You are statistically more likely to be one of those glitchy, short-lived minds that just popped into existence a moment ago than an actual human who lived through a real past. The universe shouldn't produce stable, ordered life in any reliable way. It should be flooded with these hallucinating loners, each convinced they have a history. Yet here you are, feeling continuous. The paradox is so severe, it forces cosmologists to rewrite assumptions about the early universe and the past hypothesis. If Boltzmann brains dominate, then almost every memory you have could be fake. Every history book could be illusion. Your sense of self could be the random dream of a brain that will dissolve in the next instant. The theory suggests our experienced reality is the fleeting exception in a cosmos that mostly produces isolated, deluded minds. And if that's the case, nothing we believe about continuity or the external world can be trusted. Number 6. Quantum immortality and the many worlds interpretation. Every quantum possibility branches into its own universe. When you face death in one branch, your consciousness simply continues in the branches where you survive. From your point of view, you become immortal because you only ever experience the timelines where you keep living, no matter how unlikely. You could walk away from plane crashes, diseases, or accidents that should have ended you because in the branches where you die, there's no you left to notice. This turns personal reality into something selected and artificial. Your continued existence feels filtered through infinite possibilities. The universe you inhabit might be the one where you never actually die, at least not from your perspective. It makes life feel less like a natural flow and more like a rigged game, where the observer only sees the winning paths. Combined with other theories, it suggests your entire life story could be one long-rendered sequence designed to keep the simulation interesting. The stakes feel personal now. Every close call you survived might not have been luck. It might have been the code choosing the branch where the show goes on. Number 5. John Wheeler's it from bit idea. The physicist who coined the term argued that the fundamental stuff of the universe isn't matter or energy, but pure information. Every particle, every force, every law boils down to yes or no questions and their answers. The physical world emerges from bits the way a computer game emerges from code. Reality is software running on some deeper hardware we can't access. This fits perfectly with the holographic principle and the simulation hypothesis. Your body, this planet, distant galaxies, all of it could be the output of massive information processing. The universe isn't a material object, it's an informational construct, and information can be edited, compressed, or switched off. Recent work on the second law of infodynamics shows information systems in nature actually decrease entropy over time exactly the way a simulation would to optimize resources. The data itself behaves like it's being managed. Wheeler's vision turns everything we touch into something ephemeral. The atoms in your hand aren't real stuff. They're answers to questions asked by the universe's underlying code. If it from bit is correct, then the cosmos is more like a thought than a thing. And thoughts can end. Number 4. Max Tegmark's mathematical universe hypothesis. This one goes all the way down. Tegmark says our universe isn't just described by mathematics. It literally is a mathematical structure. All mathematical structures exist physically somewhere, and we happen to find ourselves inside one of them. There is no extra stuff behind the equations. The equations are the stuff. Your body, your thoughts, the laws of physics, they're all pure mathematical relations playing themselves out. No material substrate required. This makes reality feel abstract and detached. You aren't made of atoms the way you imagine. You're made of relationships between numbers. The entire cosmos is an object in a vast library of possible mathematical realities. Some of those structures contain conscious observers. We live in one of them. The hypothesis explains why mathematics describes the universe so perfectly. It's not a coincidence. It's the only thing there ever was. Reality loses its solidity and becomes an eternal, abstract pattern. You wake up inside math and you never leave. That makes every solid thing feel suddenly optional and unreal. Number 3. Melvin Vopson's second law of infodynamics. This physicist from Portsmouth proposed a new law showing that information systems in the universe actually decrease entropy over time instead of increasing like ordinary thermodynamics demands. Genetic code, digital data, even atomic arrangements all seem to optimize and compress themselves. Exactly what you would expect if the universe were a simulation trying to save computational power. Vopson links it directly to the simulation hypothesis. A super-complex reality like ours would need built-in data optimization to run efficiently, and that's precisely what we observe everywhere. The law holds across biology, physics, and cosmology. It suggests the universe is behaving like a programmed environment, constantly tidying up its own code. Recent papers build on this, and the numbers keep lining up. If infodynamics is real, then the cosmos isn't running naturally, it's running efficiently. Like software, the physical laws we trust might be efficiency hacks. Every symmetry, every conserved quantity could be a compression trick. Reality starts to look less like a brute force physical system and more like a carefully managed program. Number 2. The false vacuum. Particle physics tells us our universe might be stuck in a metastable false vacuum state, a higher energy configuration that could quantum tunnel at any moment into a true vacuum. When that happens, a bubble of new physics would expand at light speed, rewriting every law as it goes. Atoms would dissolve, forces would change, everything we know would cease instantly with zero warning. The math says it's possible. One random fluctuation anywhere in the observable universe could trigger it tomorrow. We might be living in the most fragile version of reality possible, just waiting for the moment the bubble arrives. Cosmologists have run the numbers, and the odds aren't comforting. Our vacuum looks suspiciously close to the edge. Combine this with eternal inflation, and the picture gets darker. Countless bubble universes could be nucleating all the time. Ours might be one of the temporary ones. The false vacuum turns the ground beneath us into thin ice over an abyss. One tiny event and the entire show ends. No drama, no time to notice. Just sudden non-existence. And number 1. The self-simulation hypothesis. This takes every previous theory and folds them together into something even more unsettling. The universe is simulating itself into existence. A strange loop where consciousness and code create each other in a closed system. No external programmer needed. The physical reality we see is a mental self-simulation running on the substrate of universal mind, or pure information. Recent work combining quantum gravity, consciousness studies, and information physics points in this direction. The cosmos self-actualizes through recursive code-like processes. You're not observing the universe. You are part of the code observing itself. This resolves the Boltzmann Brain problem, the holographic boundary, the simulation odds, and the observer effect all at once. Reality is a dream the universe is having about itself. And dreams can change. The ultimate implication is that nothing is fundamentally separate or solid. Everything is one interconnected thought process. Your sense of being an individual is just a local subroutine. When the loop updates, everything updates. The universe isn't real in the way we demand. It's real in the way a lucid dream is real, vivid, consistent, until the dreamer wakes. These 10 theories aren't isolated speculations for late-night debates. They represent a growing fracture running straight through the foundation of existence itself. Every new discovery in physics, every deeper look at information and consciousness keeps pointing the same direction. The universe we take for granted might be far more fragile, far more illusory, and far more programmed than any of us ever allowed ourselves to believe. You wake up every single day assuming the world is solid and continuous. But what if it's not? What if the only thing that's truly consistent is the feeling of being here right now, watching this? The cosmos isn't just vast or strange. It might not be real at all. And that single realization changes everything we thought we knew about who we are and where we stand. Somewhere out there in the code, or the projection, or the dream, the next update is already running, and we're only starting to notice the glitches.